Alright, here's another example of function transformation. In this example, we are going to use the natural log function ln of x. And recall that the natural log function ln of x is just another way of writing the logarithmic function with base e in terms of x. So using the same order of operation Pam does, we are going to start with using the same order of operation Pam does, we are going to start with the parentheses first. Now the parentheses again represents either translating to the left or to the right by a finite amount of units. Well, we are going to have something inside parentheses because we are translating the graph of ln of x to the right by 3 units. So that means we are going to have ln in terms of x minus 3. That's done. And yes, so the parentheses is done. Exponential power, well, we don't have any. Multiplication, we do. We have to vertically stretch this function by a factor of 4. So we take this function and multiply by 4 on the front, like that. Okay, and that's a little bad. Yep. But we also have another multiplication, which is by the minus side because we are also reflecting this graph across the x-axis. So take this whole thing and just tackle the minus sign on the front. And since we are out of transformation, the function that represents all of these three is f of x equal to the product of -4 and the natural log of x minus 3. Now when we graph it out, of course we start graphing with the parent function ln of x. And recall that the graph of the ln of x from left to right is going to go through the point 0, 1. And it's going to look something like this. So this is ln of x. All right. Now the next transformation that we have to do is, as still following the order of operation, is a translation to the right by 3 units. So we take the most recent graph, which is this one, and we just shift this whole graph to the right by 3 units. So this point would end up where at 4. So 1, 2, 3. And it's just going to look something like, I don't know, I'm just going to try my best on this. It'll look something like that, okay? And yeah, it's going to look something like this because, because in the graph of the parent function ln of x, there's a vertical asymptote at x equals 0, which is the entire y axis. So if we move the whole graph to the right, let's see, I'm just gonna sketch a vertical asymptote here on the y-axis. Well, if we just move the whole graph of the parent function to the right by 3 units, then that means the vertical asymptote is just going to shift to the right by 3 units as well. So that's why the vertical asymptote is now at x equals 3. Now the next transformation that we have to do is vertical stretch by a factor of 4. So we just take this whole function, the most recent one in the red, and we just stretch it up by a factor of 4. So it's going to look a lot taller than the one in red. So it's probably going to look something like, let's see, I don't know how, probably going to look something like this and that. Right? So this is 4 times ln of x minus 3. Now lastly, we are supposed to reflect the most recent graph in the blue across the x-axis by the minus side. So we take this graph and just, quote unquote, flip it vertically. So this end will end up here and this end will end up there. So it's probably going to look something like, I don't know, like I'm just going to try my best on this. Something like that. So this is -4 times ln of x minus 3. And yeah, that is how we graph each transformation of this function.